Okay, good evening everyone. Am I audible to everyone?
Yes, sir.
So today we'll discuss about the upcoming topics. We are going to discuss today about the applications of energy storage in renewable energy integrations and also the characteristics of energy storage, device energy density, power density and efficiency. Right, in the last class we have gone through the overview of an energy technologies. What are the battery technologies we have in how we are going to store the energy in the form of either maybe ultra capacitor, super capacitor or lithium or lead acid batteries or fuel cells, right? So today we'll discuss about the characteristics of energy storage. So how we can have the graph between the power density as well as energy density and its efficiency while storing the energy in the batteries, right? So we shall discuss about the energy density, power density and the efficiency of the in the energy storage, right? So we are going to discuss about the point number 3, that is the characteristics of energy storage device, energy density, power density and the efficiency. So along with we'll study the application of energy storage in the RES for and also as well as in the microgrids and EV. So, right. So let us see what is the energy storage. There is power for energy density and the efficiency, right? We'll understand the key parameters which can define how well the energy storage system can perform and why they matters for our energy future, right? So we'll see how the energy can be stored, how faster we can discharge, how faster we can charge our energy storage things, right? And we'll see its performance, how it is going to perform during the charging and discharging of your energy storage of your batteries, right? Especially in the renewable energy and also during the time of your electric vehicle chargings, right? How these parameters, that is the power density, energy density, power density and the efficiency, how this will give an impact in the energy storage, right? That is what we are going to discuss. So we'll see the various challenges, why the storage is very important, right? Why we call it as a in the especially in the renewable energy. When we talk about the renewable energy, there is a scarcity of the generations, right? So if there is scarcity of the generations, we are going to store the energy from the renewable or the wind. You can say from the wind as well as from the your solar energy as well. From the PV modules we can generate the power, from the solar cells also we can generate the power, from the wind farm also we can generate the power, right? So that can be stored in the form of either in the from chemical to an electrical energy or electrical back to the chemical back to the electrical energy which is given to the loads from the PV panels to the loads, right? So in the renewable energy sources like solar and winds are inherently variables, right? So because why it is going to vary means because of we have the resources, where the resources in the majoring for the PV cells is the sun. The sun, we have to have the radiations. So during the sunny days we require a lot of uh, okay, I request everyone to please join immediately. Okay, so all right. So we are discussing about the why the storage is very important and why it is a playing important roles in our renewable energies also, right? So when you talk about the renewable energies, the sources such as solar and the winds, which are inherently variables, right? Because with respect to the when you talk about the with respect to resources, the resources may have there is a partially it may have the sunny days or partially it may have the rainy days also. Because of that only it is going to have some variations. That's why these renewable energy like solar and wind have the inheritance variables in their resources, right? So when you talk about the sun which does not always shines, right? That we know that from the morning to evening we can have the radiations in the after 6 p.m. after like around 7 p.m. we don't have that much of radiations to generate the power, right? So when you talk about the wind does not always blow, we cannot depend upon the winds. So that's why we had to go for the integrating these two renewable energy resources for the energy storage, right? So the energy storage will have the gap between these two, where we can get the supply and demand as I discussed in the last classes. That is the supply and demand, where we are going to have the supply and demand has to be matched. So because of this supply and demand matching of these two parameters, we have to integrate the renewable energies, where these renewable energies will have the intermediate of the its resources, right? Partially it may be cloudy, or partially it may be of rainy also. Sometimes the wind may blow, or sometimes wind may not be blown. So that's why, based on this, so we are going to to have the energy storage that creates a gap between these two. For the, that is what I'm discussing about the supply and demands, which we have discussed in the last classes, right? Which ensures the grid stability, right? We have to keep the grid to be more stable, right? Either you can generate the from the from the solar, or you can generate from the wind also, and store the energy in the form of your batteries, right? So from the batteries, you make sure to keep your grid to be more stable. Always you should have to keep your grid to be the more stable. So let us discuss our main our agendas. That is, we have to discuss more about the energy density. What is the actually energy density, and what is the power density, right? So energy density will tell us very clearly that if we take about the your batteries, right? So if we take the example of the batteries, we can call how energy density will make a impact on these parameters, right? When you talk about the ultra capacitors, we can see how quickly it will can deliver, or it can absorb the energies, right? So energy density will say that how much of energy can be stored, right? And per unit, or a volume, or a mass, right? And the power density, what is the power density? It will tell how quickly that energy can be discharged, or it will be delivered, or it can be absorbed. That is what the difference between the energy density and the power density is, right? As I've given example for the energy density, it is a battery storage, where the power density, we can take the example of the ultra capacitors. All right. So next parameter is efficiency, right? So how much of efficiency from the especially from the source and to the loads. In between there is a I told between source to the loads we have the gap. We have the bridge gap. That is, we are keeping the batteries, right? We are keeping the batteries, where we are going to take the power from the your resources such as your solar and wind, and that can be converted from light energy to the electrical energy to the chemical energy, then chemical back conversion to the electrical energy, which is sent to the loads. So in this aspects, we have to discuss about the efficiency, how efficiency will matter in this, right? How much of energy is retained through a full charge or discharge cycles, right? So during the charging and discharging of your batteries, how much of energy is being retained through the full charge and discharge of the cycles, right? So for that, we'll discuss one by one the how efficiency, energy density, and power density will matter, right? So we have to study its actual characteristics, right? If you see the energy density, how much it can hold, right? So energy density measures the amount of energy stored per unit volume or a mass, right? Or you can say the watt hour per kg. We can say it is a watt hour per kg. Higher the energy density means more energy in smaller, right? So that is what the lighter package, or you can say the electrical vehicle or portable electronics. Especially as given the example of the batteries, right? So when you talk about the energy densities, we are taking the example of the batteries, because batteries can store the energy, it will discharge, it will charge, right? How faster and how much of amount of volume of energy is stored in terms of per unit, right? In terms of the watt hour, or you can say about the watt hour per kg, right? So that is how, and how much of energy density means the more energy is in a smaller or lighter packages, right? We'll see how this energy will matter, how this energy density will matters in the batteries, right? So we have taken example our lithium batteries, and also we have the hydrogen fuel cells, right? Where we have given the example of 500 to 3000, and here also we have the 200 to 5000 watt hours, right? So which is dominant in the EV, right? Where we have taken the for the EV, dominating EV and the consumer electronics also for the lithium ion batteries. If you see the power density, how fast it can deliver. As I told, the power density speaks about the how faster it is going to discharge. That is given the example of the capacitor. You can see we have the capacitor over here. This capacitor is going to discharge the actual energy, right? So it will be very more faster as compared with the batteries, right? The batteries will take more time to charge and more time to discharge also, whereas a capacitor, the super capacitor, will talk about the fast discharging, that is how fast it is can deliver the power to the loads. That is what we talk about the power density. Power density will tells about the how fast it can deliver your the power. Right. So this is the examples we have taken to understand the ultra capacitors, the flywheels, as well as the lithium batteries and lead acid batteries. Right. So the more faster power can be delivered, especially in the power in the ultra capacitors, whereas in the if you talk about the batteries, right, the energy density will be very less. We can say the discharge time, the discharging power from the batteries will be very less as compared with the super capacitors. Right. So what actually it means, the power density which measures the rate at which the energy is delivered, right, means how fast you can deliver the energy. As I given the example in the last class that we have talked about the ultra capacitors, right, which are used in the mainly for electric vehicles, right. It will charge more faster and it will discharge very quickly. So that is what the power which is delivered, the power is going to be discharged quickly and power is going to absorb very quickly. So that's why these ultra capacitor or super capacitors are used in the electric vehicles, most of the electric vehicles, right? So this the amount of the rate, the power density which measures the rate at which the energy is going to be delivered or absorbed in terms of per unit volumes or a mass, right? The high power density is essential when a rapid burst of energies are required. So suppose if I want to have the quick amount of discharge, right, I will be switching over to the super capacitors, right, where I want to make the grid stability, I want to make my grid more stability, right. I've given the example in last class about the power qualities, right. If you want to improve the power qualities, you have to go for the super capacitors, right, where this discharging of the capacitors will have to will make your improve your quality of the power in the grid for the grid stabilizations, right. And also in especially in case of the RB also, that is regenerative brakings, and for EV accelerations also, right. So where we want to start with the where we want a quick start, so during that time the power deliver should be very more faster. So that's why we use for the capacitors in the grid stabilizations as well as in the regenerative brakings, right. Next we'll talk about the efficiency, right. Efficiency is nothing but if we talk in general, efficiency is nothing but the how much of lost, that is how much of lost is being considered, right. For example, usually we talk about the efficiency considering the two things, one is the input and other is the outputs, right. So output by input will gives actually your efficiency, right. When you multiply with 100 it will gives efficiency. Actually what is the output, how much of output of power is delivered to the loads, and what is the input, how much of input is taken from the your during the time of generations, and how much of losses will occur, right. We have to look after this, the efficiency, that is the efficiency measures the what fraction of input energy is successfully recovered as the outputs, right. The minimizing the losses means the lower cost and the better performance. If you see the most of the superconducting magnetic storage, and there is a high cost of high trip of efficiency, that is 95 to 80%, 95 to 85 98%, right. When you talk about the batteries and the super capacitor, it is almost gives an efficiency of the 90%. When you talk about the that is TS, that is thermal energy storage, right, it will be having a very less efficiency, which is depends upon the design of your configurations, right. So efficiency will see about how the output and the input will matters a lot, and also the losses, right. How much of output is delivered to the loads and how much of input is being provided from the resources, right, and how much of loss has been occurred during the time of providing the power from input from the source to the loads, right. We'll just see how the efficiency can be calculated. So right, so these are the most of the business things where we just look for the kind of the batteries for the storage, right. Energy storage technologies will talk about them in various dimensions, right. So when you think about the while following the short in other things, the right choice depends entirely on the application wise. As I told, the energy storage maybe differ in the different ways, based on the technologies, how we are going to store the energy, how we are going to utilize that energy, in what are the actual applications we are going to use the specific energy storage. right? So if you see the lithium ion batteries which are used in the EV sites, right? If EV sites where it can have the maximum of energy density from 150 to 250, that is watt hour per kilograms. That would be the very good power density, and we should think about the energy densities also when you talk about the batteries, right, along with the efficiencies. So when you think about the super capacitors, right, the super capacitors may have the high power densities, right, and the low energy densities. And exceptionally life cycle will also be the exceptional life cycle we can have, but the lower energy density, as I told, when you go for, you should have to compromise for one thing. So either you want to go for high power densities, or if you want to go for lower energy densities, then you have to switch over to the super capacitors, right? Or else if you want to have the high energy densities and low power density, then you have to switch over to the lithium batteries, which can be used for your electric vehicles of your EV applications, right? So similarly we have the other storages also, where we have to gone for the, in the last class, the pumped hydro storage, right? So let us discuss. These are the various things which matters in the form of for application wise for the business purpose, right? How the peoples are taking the this considerations for their applications, right? So if you see the energy storage, we have the energy storage entire ecosystem, right? So this actually the ecosystems will talks about the how the different forms of energy can be stored in different ways, right? We don't think about the more about it is fully based upon the this ecosystem will be based upon the application wise, how we are going to use this for specific applications, right, in the real world of energy systems, right? This is actually the portfolios where these energy ecosystems can have the different various forms of the energy storage, right, which may match with the each energy technologies that can be used in a case where it perform the best, right, where you are going to use in a specific way. For example, I was told about the super capacitors which can be used for the high power and low energy densities, right? And if you go for the SMS, that is high efficiency have, we have to compromise with the other two parameters, that is power as well as the energy densities, right? So this is actually the ecosystems where we have to see the various forms of the parameters where we are going to store the energies with respect to the with respect to the various storage technologies, and it's how we are going to use in the different ways, and whether if you want to use for the short durations or high power, then go for the super capacitors and the flywheels, right, which can handle the rapid frequency of regulations. It will try to make switch, it will try to discharge quickly, it will try to charge quickly also, especially in case of the uh, super capacitors, right? Uh, Let us see, somebody's been entered into the online class. Okay, Salma is been entered. Okay, I've been admitted him. Okay, all right. So we are just discussing about the various forms of the energy storage in the ecosystem and the balancing ecosystems, where we have to go for the switching to the various forms, right? Uday, am I audible?
Yes, sir.
Um, if you have any queries, you can ask me, okay, in between, no issue. All right. So for as I told, for the short durations for high power density, then you have to compromise with the other two parameters, right? Especially with the efficiency and the energy densities also, right? Especially for that, we are going for the super capacitors and the flywheels, where we can have the rapid frequency regulations, right? Where you can we can have the completely discharge in a short durations, and we can have the quickly charge in the very short span of times, right? So when you talk about the medium duration flexibilities, then you should switch over to the lithium ion batteries, where it will balance the your both the grids, right? That is hybrid grids. When we are talking about the solar and the winds, where we can have the variabilities, the charging from the one source, and during the when resources are available, if you don't have any resources, then you can go switch over to the your wind turbines to have the your storage. That is how the we are switching to the lithium ion batteries. It will slowly it will charge and slowly it will discharge. So that's why we are mostly be using the renewable energies, right? Where the integrations of the renewable energies occurs, there we can switch over to the medium durations, right? It will charge with more times, it will discharge with more time also, right? So when you talk about the long durations and the bulk storage, right? If you want to have the very long time and enormous of storage, right? We should go for the pump. We can go for the air compressor storage also. We can go for the pumped hydros also, right? Especially in the small scale grids, that is the microgrids, wherever it is required, right? Okay. Let us see, there are the various forms of these storages, the thermal energy storage or a compressed, where the storage energy can be in the underground also, right? Compressed air is mostly on the undergrounds, right? In the caves, like it is beneath your beneath the earth surface, where you are going to have the compressed air will be pumped back to be stored and it will be generated for the energy storage, right? And when you talk about the thermal energy storages, the power is, as I told about, the power is very very less in form of thermal energy storage. That is what it is. Efficiency will be around 40%. Yes, 40% of efficiency will be there. That is what the thermal energy storage have very very less efficiency. Everything it depends upon the configurations, how you design the complete the systems. So, all right. So, upcoming days, we can have the different kinds of the innovations which we develop in the future days. Hybrid storage also may have. You may have the advanced electrode materials. We can have the solid state electrolytes also, where we can have the double form of double electrolytes for storing the your electrical energy in the form of charges, right? Where it can have improve your energies also. It can improve your safeties also. It will improve the life of the batteries also. So that is what the in upcoming days we have the lot of innovations, right? When you make a research on the for the battery energy systems, right? Because most of the companies, most of the industries, they are making a lot of research, right? Most of the R&D department, they are going to have these kinds of research, where we can have the various things. There should have some drastic improvement, where we are just compromise about the energy. Sometimes you want to compromise about the power, right? So if we get all together at a time, that would be very better. More power and more density. Sometimes less power and more densities, where the mismatching of these things is happening. So we have to think more about the different forms of how the energy can be stored in the various forms for longevities, and also the life of that batteries has to be increased in the future days, right? So, and also if you see the hybrid storage systems also, right? So where we can have the multi technologies of integration spheres with the strength of each type. So combining the power with high energy in a single system. That is what I was expecting. Right? So we have to think about where you are compromising for the, sometimes you are compromising for the energy, sometimes you are compromising for the power. If we talk about the batteries, as I told, in the batteries, you have to compromise about the power, but energy will be more. When you talk about the ultra capacitors, we have to compromise about the energy density, no bothering about the power. So if you want to have all together at a times, so you just have to integrate. So you just have to make some novelties and the research where this can happen at a times, where the multi-technology, if you use a multi-technology integration, no, the multi-technology integrations, the pair of strength of each type. I want to have both the parameter in one modules, right? So that is, I want to combine the power and the energy at a times, because I want to have the high power and high energy. I don't want to compromise for low energy, high power, and low power and high energy, right? I don't want to have that kind of system. So that's why we have to go for the hybrid storage systems, where you can This will be very useful for the, especially in the microgrids and renewable energies also, and energy storage for in terms of gigawatt or megawatt. So this will be for the grid stabilization. So it will be very useful, right? So these kinds of innovation should be happen in the upcoming days, right? So most of the researcher has to look after this, right? Especially they have to think about the battery energy storage, its chemical properties, its composite materials, all the factors they have to think how the hybrid storage can be happen, how we are going to improve the power, how we are going to improve its energy density, its power densities, right? We have to make the lot of keeping in that mind, we have to see how this power and high energy density can be happen all together. All right, so this is about more about the keeping the powering sustainable in the upcoming days, right? The future is to be stored because we have the lot of solar panels in the pagodas also in the Tumkur districts, right, which is in the Asia. It is the best one where they are going to generate the enormous of power from the PV modules. They are being be stored and the batteries for the later use, right? So this is how in the future days it should be happen. Where upcoming days we should have these sustainable, means there should have a lot of sustainable in the energy. We should not go beyond the scarcity of the powers, and we want to have the enormous of power during your enormous of power during your work times also, right? We shouldn't have any the power cut. So for that reason, you have to go for the storage only. That is, in the upcoming days, we have to think about the sustainable. We have to sustain. We have to complete. We have to execute our work means we have to go for the energy storage because the power is essential for everyone. Nowadays, without power, you cannot do any work only, right? So most of the things will get stuck if you don't have the power. If you take about the electric mobilities also, your EV, which is fully based on your AC charging. Sometimes it is based on DC fast charging also, right? Where your batteries are going to be have the storage, right? If you see about the grid resilience, when you talk about the grid resilience, it will tell us about how faster it can react for the faulty conditions. Faulty condition has to be recover back in a fraction of minutes. That is what the grid resilience. That is, it should have to have the more when the fault occurs, right? It should not have the longer times to clear the faults. So that is what we think about the grid resilience. Okay, so grid resilience. When you talk about the grid resilience, how much the grid can have the stability, right? How the grid can have the more stabilities during the faulty conditions, right? It has to withstand, right? It has to withstand for a fraction of seconds, not the fraction of hours, right? That is called the grid resilience, right? So for that you have to inject, as I told, the when you go for using your super capacitors, where the grid resilience can be overcome in a with a fraction of minutes also, right? And make the system to be more stable, right? And it can have the continuity of the power. Reliable means the continuity of the power can be possible from the variable renewable resources, right? At any point of view, right? We have to have see the resilience also, and this resilience has to be recovered very in a fraction of minutes. That is the faulty conditions. When the fault occurs, it has to be recovered in a fraction of minutes. It should not take much time in the grids. If you take much time, you have to you cannot give the reliabilities. Yes or not? If you don't give the reliabilities, what will happen? The people will think about there is no power. They cannot have their any productions. They don't have their running their any other equipments, right? So these things will happen. So we have to recover our faulty conditions, right? Especially in the when the grid have the any faulty condition, this resilience will matters a lot, right? So for that, to make the more stable, the storage is also very important, right? In the form of in the various forms, it may have in the various forms of the storage. That is at any point of view that you can have the energy resources for the storage also, right? From the storage we can have the faulty can be cleared in a very easier ways also, right? So where the grid have the more stability and the more reliability can also be happen. And when we talk about the electrical mobilities, right? So when you have the storage, right, we have the lithium-ion batteries where you are going to store your energy. We have to think about the energy densities. We have to think about the efficiency. We have to think about the power densities also, right? When you have to see about the electrical mobilities in the future days, right? Higher density and efficiency will matters a lot for the especially in the EV. where we must have the longer range and the faster charging for the EVs. That's why we have been. That's why the people most of in the market we have the EV fast chargings, right? And then we have the EV fast chargings. So where you are going to have the fast charging of the EV batteries, right? In the electrical mobilities, right? If you think about the efficiency, right? The efficiency should have more, and density will also should have in a gooder way, and also which can step forward to the net zero emissions in the upcoming days, right? So we're just looking for to have the more kind of high power densities, high energy and high efficiency, right? We will not compromise for any of these three factors, so that there may have in the upcoming days in the year 2050 or 2040, or we have the completely the zero emissions from the electric mobilities, right? So that's why we should think about the all these parameters, that is the power, your power density, your energy density, and as well as your efficiencies also. All right, so let us see how the supercapacitor and the battery will comes into the picture, right? I hope it is clear to everyone. Uday,
Sir.
is it clear? All the slides it is clear to everyone what I have discussed so far.
Yes, sir.
Oh, let us make the comparisons, right? Let us make the comparisons of any one of the storage, right? With your supercapacitors or with the batteries, right? We'll see how this the power density and the energy density will matters, right? How we are going to make the what do you say, the various parameters, right? And which we have to make the compromise, and which should not we have to make the compromise. Ultimately, we have to think about the long durations, right? And the bulk storage. That is what we are going to expect. We have to have the life longevity of your batteries, your maybe your capacitors, right? We require the high efficiencies. Everyone is looking for the high efficiency and high storage also, and high power densities also, high energy densities also, right? Let us see how it will things practically will think the practically, right? So if you see in this x-axis and the y-axis, right, there are it is a two-dimension graph, right? Let us see the energy density in the form of watt hour per kg, right? Where the power density in the y-axis we have the kilograms. Understood? So in the x-axis we have the energy densities. It is a watt hour per kilograms in the x-axis. In the power densities in the y-axis we have the power densities in terms of watt per kilograms, right? So we shall consider the capacitor and the batteries, right? How this will be, which is dominating in which factors, all right? Whether the capacitor is dominating in the energy or battery is dominating in the power. Let us see if we keep these two parameters at a time. When you make the comparison between the supercapacitors and the batteries, we'll see how this will make the impact on the your power density and energy densities with respect to its units of the watt per kg in terms of for the power densities, and watt hour per kg for the energy densities, right? So if you see these diagrams, it is very clear that the battery have the may have the more volumes and the more mass, right? Whereas super capacitor will have the less volume and the less mass also, right? If you see in this, we have given the example of if we take about the your storage, right? So both are storage only, right? Both are storage. In this we can see the super capacitors, right? The discharging is very faster. Correct? Is it correct, Uday? Yeah, Uday, it is correct.
So can you repeat once? I'm not.
But in the batteries also, there is a discharging is you can see there is a very narrow, right? Here you can see it is a very broader also the discharging. Here also you can see there is a very narrow for discharge, right? And the more volume you have in the batteries, right? Where the batteries, as I told, in terms of if we talk about the energy densities, that is watt hour per kilograms. Whereas in power densities, it is watt per kg. right? So if you take the example of your storage in the water tank of your storage, right? So if you keep a pipe, or you can say the tap, right? So if you storage, for example, if you have a batteries, if you have a storage, right, in the your water syntax, right? It may be contents of 1,000 liters of water or 5,000 liters of water, right? So if you connect a tap for that, right? So it will, the water will come very slowly. It depends upon the pressure, right? The potential energy which is there in the storage, that is your tank, right? If you see in the super capacitor, right? The discharging is very very faster, right? The volume of the discharging is very very faster, and when you talk about the batteries, right, the discharging is very very less, right? So this is what the differences we have been observed in these two. So where the volume and the mass will matters a lot in the storage, right? If you take about the water tank, where you are going to have the 5,000 of liters in your water tank, right, in the, which is stored in the on the terrace, right, which is connected to the your pipelines to the next to the tap. When you turn on the tap, what will happen? The water will come with a very high pressure, right? High potential, it will come from the for a high potential, right? The water will be coming in the tap with very very in a very smaller way, right? Means the discharging, if you see, the discharging is very very less, right? If you use the same things, if you use the same thing for super capacitors, where you can have the more discharging, the more faster, right? If you use the bigger taps, it will be the more faster. The volume from the storage is become the more faster, right? So here we have noticed that in the batteries, the discharging of the energy, right? The discharging of the energy is in the form of like watt hours, where it is going to discharge in a very slower way, but it has contained certain kinds of energy where it is being stored, but discharging is very very less, right? Whereas in super capacitor, we say that it is more faster, the more faster it is going to discharge, right? So this is what the two things we have to make the comparison, right? If we keep the capacitor on the y-axis, if I keep the capacitor over here, and if we keep the battery here, right? So if we plot the graph between the battery and the capacitors, then we'll see how the power density and the energy densities, these two makes a lot of impact on the super capacitor as well as the batteries. So which are used for the particular applications, as I told, this can be used for the both are also can be used for the EVs also, where depends upon the applications of the usage. All right. So here we have the uh, energy densities in the x-axis, and in the y-axis we have the power densities. So all right, somebody's been entered now. Okay, okay, Salman, are you audible? I'm audible. Okay, Shivraj. Okay, Rashmi. Okay, Uday.
Sir, yes, sir. Yes.
Okay, all right, no issue. Okay, fine. So I was talking about the super capacitor and the batteries, right? So where we are going to have the super capacitors on the across this side, and the batteries we are going to keep over here with respect to the energy density, because we are following the various parameters. A battery may have the more energy densities, where the super capacitor may have the more power, right? If you see the variations between these two, right? If you see the variation in these two, see the batteries, right? So if you want to have the more energy, right? If you want to have the more energy, the batteries may have the less power. Yes or not? So if you see here, the batteries may have the less power and more energy, right? When you talk about the capacitors, right, the capacitor will have the more power but less energy. If you see that there is a less energy in the capacitors, This is how it makes a lot of difference between the supercapacitor and the batteries. All right. So in the supercapacitors, it may have the more densities, that is watt per kg, where the batteries will have the more energy and less power. So this is what the actual difference is. If you keep in between the supercapacitors, right? We have the capacitor, we have supercapacitor. The capacitor, if you see the capacitor, that is what we are thinking about the future. We want to have in both at a time. That is, we are expecting for the to have the more power density as well as more energy at a time. So that's why we are looking for the supercapacitor to be have the more novelties in that making doing making the research and to make the implementation to develop the new products, right, which can have the both the parameters at a time. That is, we need to have the power densities should be very higher, and also the energy density should also be very higher. As we talk about the capacitors, may have the higher power, S or not. We can see there is a higher power here, but in the batteries, if you see in the battery, the power is very less. See, if the power is very less, right, but energy is more. Right, the delivery of the power is very less, but the energy is very high. When you compare with the supercapacitors, right, the supercapacitors will have the more power and the less energy. Right, if you keep in between the supercapacitors, we may have, if you see the supercapacitor, right, the power is also almost in the as dominating with the these batteries in form of the energies also, right, and also with the capacitor it is also dominating with the power. So both may have in the future. That is what we have to think more about the to have the both the parameters. That is a power, that is a power density as well as a energy densities. To understand this, we need to have what is a power density. That is, one is power density is compromised. It is compromised for the energy density, right? If you see about the power density, see this power densities is very high, right? When you talk about power density is very high, then you have to compromise about the energy density. See, energy density is very less. See, when you talk about the capacitors, right? I'm talking about the capacitor for the in terms of power densities. That is watt per kilograms, right? So we cannot have the energy densities, right? Energy densities will be very less. That is what you have to go for the compromising with the energy densities. If you go for the capacitors, when we look for the, especially in the grid stabilization, right? In the grid stabilizations, we are going to make the grid to be more stable. So we are switching the capacitor for the improving the your power qualities to make the grid stabilizations, right. Then during that time, if you switch over to the capacitors, the power density will be, we have to compromise with the energy densities only. The power will be more dominating when compared with the energy densities, right. So this is actually this picturization will tell us about the capacitor may have the high power densities. All right, the capacitor may have the high power densities, then you have to compromise with the energy densities. All right. So when you talk about the batteries, the battery will vice versa of it, right? So if when you talk about the batteries will have the densities, the power densities will be very less, right? If you see the power density of the batteries will be very less, as when you compare with the energy density. The energy density will be very high as compared with the if you see here, the power density is very less. All right, and the energy density is very high. If you see, the energy density is very high, right. If you want to have all these two, then we have to see about the super capacitors, right. So the super capacitor is the only one solution. If we want to have the highest power and high energy density, then we have to think about the design of these ultra capacitors also, right, which will be more useful for our grid stabilizations and various things for various applications also. So, all right, energy densities or the power densities, as I told, energy density decides how far you can travel, right? So let us see, if you want to go for 5 kilometers, right? If you want to go for 5 kilometers, right? Sometimes you may run very fast, sometimes you may run very slow, right? But you should have the energy to reach from source to destinations, right? How far you can travel, right? Minimum, for example, you can travel from 0 kilometer to, if you are traveling for 5 kilometers, right? So sometimes if you go for from 0 kilometer to 10 kilometers, right, it means that the energy will be there how far it will try to deliver to the loads, how far the energy can be delivered, right? It means that you have seen in this diagram, in the last diagrams I have shown it very clearly, that the energy in the batteries, right? So there is a high volume of mass, right? High volume of the energy stored, right? So it will take a long time to discharge. It will take long time to discharge the energy. I hope you understood. It will take the long time to discharge the energy, right? So that is what if we see in the energy densities, how far you can, that is example we have taken, how far you can going to travel. Either if you travel for 5 kilometers, you can travel from 0 to 10 kilometers, right? But you require the energy, correct? If you don't have the energy, what will happen? You cannot go for that amount of energy. You cannot travel that amount of energies, right? Shivraj, are you there? Okay, Sanjita, Mamta, Sneha. Okay, Salman.
Yes, sir.
Okay, are you following now what I'm telling about the power density and energy density? Sneha.
Yes, sir.
Okay, Uday.
Yes, sir. Yes, I follow, sir.
Okay, fine.
Supercapacitor energy density is very low, sir, and battery is very high, and power density supercapacitor is very high, and power density very medium, sir.
Yeah, exactly. That is, I'm giving the one more example to make you very clear the concept, right? We'll say with the
Yes,
same
sir.
example,
And
you'll understand very better. All right. As I'm discussing about the energy density, that it will decide how far you can travel, right? You can travel for 5 kilometers, you can travel for 10 kilometers, right? Isn't it? But you require the energy. Yes or not? If you don't have energy in your body, you cannot travel. Correct? You can walk very slowly also. Am I correct? You can walk very slowly also for 10 kilometers. You can walk very faster also for the 10 kilometers, right? How much of energy is there in your body? So that will matters a lot. Correct. So that will matters a lot for the, especially for the batteries. The battery is going to discharge. So battery is going to be discharged. When it may be in a very slower way. That is, I told that it discharging and charging. That is what we discussed in the state of charge and state of health of the batteries in the battery management system, right? So here the energy density will decide how far you can travel. If it is possible to travel for 10 kilometers, it may very slowly, you can walk also, right? You can go very slowly, but you require the energy. You can go very fast also in a very slower way, but ultimately you require the energy, right? Energy will matters a lot, especially in the batteries. So all right. So whereas if you see in the power densities, right, it decides how fast you can travel. Power density is nothing but for the same distance. If you take for the same distance of 10 kilometers, you are going very faster, right? Decides how fast you can travel. That is nothing but you are going to reach the destination from 0 to 10 kilometers, right? You are reaching in a very less time, correct? You are going in a less time, applying the more power in your body, right? Whereas in energy density, it may takes more time, it may takes more time to discharge, it may takes more time to reach the destinations, right? Whereas in the power densities will decide the how fast you can travel, how fast you can run, right? How much of power you are going to deliver ultimately you are going to deliver the maximum power, right? You are going to deliver the maximum power, how fast you can do it. That is what we are making to understand the power densities, right? Power density is nothing but the more faster, and energy density will decide the how slower it will try to discharge the energy, right? So if you see this definitions, the energy density will tells how much energy the device can store, correct? Just like as I told the example of your syntax, right? Syntax, you have the 1,000 liters volume of water, right? You have the 1,000 liters of volume of water. This syntax is connected to the any tap, right? If you connect to any tap through the pipelines, right? You are going to turn on your tap. So what will happen actually? 1,000 liter of waters will come to the bucket, right? So it will take more time. Yes or not? It will take, again you have to replace the n number of buckets, right? If you want to completely to remove the water from the tank for 1000 liters, the time will takes more. Yes or not? Will take very high time it will take, right? So that is what I've given the example of the for energy density for the storage of syntax of water, right? So syntax of water which is connected to the through the pipelines and it is coming to the your tap. When you turn on the taps, the filling of water into the bucket, right? To empty that syntax of 1000 liter of volume of water, right? So it will take a much time, right? It can take a much time because of the energy, because of the energy density, and the power is because of the energy densities, right? If you take other examples, device having a high energy densities can supply the current for a longer times, correct? So if you have the energy densities means we can supply the we can supply the current for a longer times. That's why these batteries are measured in terms of ampere hours. That's why if you use in your mobiles also, no? If you see in the mobiles, it is 5000 mAh, 2000 mAh, or 500 mAh. Like these are the examples I'm giving you, right? Means it will how much of current can be delivered with respect to time. So 1 hour, for example, 1 hour, you are going to deliver of 10 amperes. For 1 hour, you are going to deliver of 5 amperes. For 1 hour, you are going to deliver of 2.5 amperes of the current. Correct. So that is what how much of volume of energy, how much of energy you are going to deliver. So in the particular time, that's why we call it as a ampere hour. The batteries are always rated with the ampere hour because it depends upon how much of current it can deliver for particular hour. So 1 hour you are going to deliver of 100 amperes. That is we when you talk about that is a C rate, right? That is a charging and the discharging rates, right? So we'll not discuss about the C rates. So we have to understand the ampere hours with respect to the energy density, right? So energy density can store for a given volume, right? So energy density, what it will tell actually how much of energy that device can store. The Syntax can store of 1000 liters of volume of water, 500 liters of volume of water, or 2000 liters of volume of water, right? So how much time it will take to fill the 100 buckets to make the empty of syntax? Completely water has to be made empty in the syntax, correct? That is what how much time it is going to take the water to be make empty in the syntax. That is called the energy density. How long it will take, how much time it will take. So correct. So that is how much of time it will take to deliver the your water from the syntax to the bucket, correct? So this would be the best example to make it a very understandable, right? So all right, that is what I was discussing about the storage area where you are going to store the volume of water in terms of 5000 liter or 2000 liter or 1000 liter of volume of water, right? If you want to make that syntax to be more empty, so what you are going to do? Right, you are going to turn on the tap, correct? How much time it will take to empty the syntax water? It will take much time, correct? Similarly, like that, the same concept. That is what. So for 1 hour, how much of current it will deliver? For 2 hours, how much of current it will means how much of coulomb of charges is going to deliver to the loads. That is from your battery of your mobile to the your PCB circuits, right? So that's why it will we have a lot of uh, the energy densities when you talk about the batteries, that is EH of the batteries, right? For 1 hour it is delivering 10 ampere of current. For 1 hour it is delivering 5 ampere of current. For 2 hours it is delivering the 6 ampere of current, right? It depends. It depends upon the your storage of your ampere hour of your batteries, right? So in with respect to that, we have thinking about the energy densities, right? So how faster, how the device can respond to deliver the current, with respect to the time, how much of coulomb of charges it will going to deliver, right? For instance, we have talked about the device which having the higher energy densities can supply the current for a longer time than one with the low energy density for the same mass of volume, correct? So that is what the example is very clear, you can understand in a very easier way about the energy densities. I hope it is clear. Uday, it is clear to you?
Yes, sir. Yes.
I've given the example of the syntax also, where you have to fill your water in the syntax of 1000 liters of water, volume of water, and keep a bucket and turn on your tap, it will take much time to empty the entire volume of your syntax. So that's how the our age of the batteries, that is a battery which are used in your mobile, it will take a much time to deliver the current. It depends upon the loads. When you connect the loads, it will try to deliver the current and the coulomb of charges. That is what they are telling. The higher the device having a higher energy density, right? Especially for the batteries, can supply the current for a longer times, right? It will supply the current for a longer time. With one, if you see with the one with low energy densities, for the same mass of volume, it will have a little differences, right? When you talk about the our power densities, right? Now, when you come to the power densities, as I told, how faster, how quick it will respond. The battery, how quickly it will respond. I have given example of capacitors, right? We have kept the capacitor on the y axis and the battery on the x-axis, right? We just compared these two power density and the energy densities. In between, we have kept the super capacitor also, right? So, with respect to the capacitor, right? The capacitor will respond very quickly. So that's why we are using in the power grids. We are using the for making grid to be stability. So we are switching the for reactive power compensating in the transmission lines, where we can use your ultra capacitors for the switching of the power devices to give the reactive power from the capacitor bank, back to the transmission line, so to make the most stability of the reactive power, right? So during that cases, we are using the power densities in the, especially in the grids, right? If you see the power density, what it will tell actually, how quickly the device can deliver the energy, how faster it is going to deliver the energy. I want to deliver the energy in a fraction of minutes. I want to deliver in a fraction of seconds. I don't want to wait for a longer time. I don't want to discharge your capacitor for a longer time. So it will cannot tell us, you cannot tell us about the energy density is very less, right? Yeah, the delivery of energy should be more faster, right? So if you see in this diagram, it is very clear, right? In this diagram, it is very clear that if you see the power, right? The power which is discharging and the energy is very more fast in an enormous way, and also the very faster and very quick it is going to respond, right? In the, especially in the super capacitor, right? The power, the energy density is faster it is going to be flow in a fraction of minutes, right? In fraction of seconds, right? And it will charge in a similar, it will charge, it will, as I given the example, I will given that, I already told that how faster it will respond for making the absorptions and making the delivery of the energy to the loads. So right, so that is what the power density will tell us, how quickly the device can deliver the energy, right? It is basically the maximum current that is drawn from the device, right, for a given mass or volumes, right? So power density will tell us how quickly the device can deliver the energy, right? So I want to deliver the energy in a fraction of minutes. I don't want to wait for a 20 minutes or 30 minutes, just like for your energy density, where you stored the volume of water in the syntax. It will take the much time to deliver the current. All right, it will take the current for a longer time, so it will deliver the current for a longer time, as we accepted in the energy density. But in case of power densities, it should respond very quickly. Delivery of energy should be more faster, especially we are using in the ultra capacitors, right? We are using the capacitor banks when the power, especially in the power grids, right? We are using we are using the capacitor to switch the reactive power into the transmission lines, because most of the devices, right? Most of the devices were the inductive loads. When you talk about the inductive loads, sometimes reactive power will also matters a lot, right? And real power, real and reactive power, these two parameters is very important for the consumption of the powers, where we have an inductive loads, right? When you have the inductive loads, so you require the real power and you require the reactive power also. If reactive power is less, also your inductive loads cannot be worked. So that's why we have to think more about the reactive power in the transmission lines. So for that purpose only, we are connecting a what do you say, the battery banks, right? So where you can deliver the quick power, right, into the transmission lines. The reactive power can be delivered very quickly. That is, the reactive power can be delivered very quickly into the transmission lines, where the transmission lines will carry the reactive power to the inductive loads the more faster, right? So that's why the power density, how quickly it is going to respond for the device can deliver that energy. That is the maximum current which is drawn from the device, right? The high current should be drawn for a given mass or volumes, right? That is will tell us about the power density. I hope it is clear to you, right? Is it clear to everyone?
Yes, sir.
Okay, all right, right. We have one more example also. You can go through this. The 1,000 meter of race. The runner needs a constant energy for a longer time, and hence your energy density should be very high. Right, if you want to have to reach for given the example of 10 kilometers, no, if you want to go for 10 kilometers, you have to have the most of the energy should be in a very what do you say, in the constant way. You require the constant energy for the to reach the destination for a longer time, right? If you lose the energy, no, if the energy sometimes you may have more, sometimes you may have less, what will happen? You cannot reach the destinations, right? That should not be happen. So that is what when we talk about this, this is one of the best example to understand the energy density, right? So we want to have the energy density, that is what they should have the constant energy, right, for a longer times. If you have the constant energy for a longer times, then only it is possible to deliver for a longer time. That is what I told now, how much of amount of charge, amount of current, right, you are dealing for the specific hour. 2 hour 50 amperes, so 1 hour 25 amperes, like 3 hours 75 amperes, correct? So that is how the batteries are rated with the ampere hours, right? How long it will give the current to the loads, right? That is a, we require the constant energy for a longer durations, right? So hence your energy density should be very very high for to have the more longer times or longevity of the to supply the energy, right? Especially for the batteries, right? Especially for your batteries. It doesn't matter for our capacitors, okay? Don't bother with the capacitors. Power is more. We're talking about the power density is very high in the capacitors, whereas in the batteries the energy density will be very high, right? So when you talk about the 100 meters, now you see we have one more example, 100 meter of race, right? A runner needs a quick power to accelerate, therefore the runner needs a high power density. Yes or not? If you want to reach the 100 meters in a fraction of minutes, right? So you require the high power. Without the high power, you cannot reach the destination. Means the delivery of energy should be very very high. It should not have the constant. Here I just talk about the constant, isn't it? Was talking about the constant. But in case of other, right, when you talk about the power densities, require the high power, means very faster and the quick response of the power should be there to accelerate the particular things or the particular systems to accelerate, right? Therefore the runner needs a very high power densities where you can have the fraction of fraction of span, the power can be delivered very quickly with the lower energy density, right? When you talk about high power density, the lower energy density will be there, right? Right. So energy density is the ability of how long you can store the energy, whereas power density is how quickly you can release it. Right. So that's why the energy density will, given the example of batteries. I have given the example of the batteries. Already I given the example of the batteries. How long you can store the energies, right? How much time, how much period, how much of long time you can store the energies in the batteries, right? The discharging will be very less, and the charging will be the charging will also be takes more time. The discharging will also take the more times, right? And the storage also, right? The storage of energy, how long you can retain your energy for a long times, right? So if you don't use for example, if you don't use the batteries, right, what will happen? The energy density will not release only, right? So if you charge the batteries for today, right, so if you don't use anything, right, if you don't use anything for your loads, so what will happen? The energy stored will be there, right? The some part of energy store will be there, right? And also if you think it will be if you are using for one day, it may have the longevitities of your energy densities, right? Where the power density is how quickly it can release, right? When you have to have the more power, then don't bother about the energy densities. All right. So when you talk about the power densities, don't bother about the energy densities. You have to compromise. There is only one thing you have to compromise with the energy densities. Okay. When you talk about the power densities, you have to compromise with the energy densities. When you talk about the energy densities, you have to compromise about the power densities. So this is the two things, right? So we are just fighting we are compromising one thing. We are don't bother about the other parameter, right? So when you talk about the energy densities, don't think about the power densities. It will be always very less. That is what the example is. The constant energy will be there, right? For the especially for the energy densities. right? In the power densities, we'll be having the quick power of release will be there in a fraction of seconds, right? So this is how the differences we have understood for the power density as well as the energy densities. So all right, so next we will go with the efficiency, right? So I was talking about the efficiency, right? Next we'll see about the power, the efficiency of your the topic, right? The efficiency, right? The efficiency, we'll discuss about the efficiency. We just discussed about the characteristics and its proper definitions of the storage, energy storage devices, right? Energy densities and power densities, right? We'll talk about the now efficiency, how efficiency will matters a lot in the energy storage, right? How the energy storage, especially in the grids, we were just talking about the hybrid. We're just talking about the that is combining your solar and the wind grids, right? Where we are going to make the storage and from the storage back to the loads, right? How efficiency will matters a lot, right? So we'll see how this makes a lot of impact. The efficiency will make an impact with respect to the your this energy storage, right? That is what we'll think about the efficiency. We'll see about the efficiency with respect to the energy density and with respect to the power densities, right? How much of efficiency it will provides. All right. So as I discussed in the earlier about the efficiency, right? Efficiency, how much is lost means when you give input, right? So when you give the input, what will happen? Output will be there, correct? Some losses will be there, correct? So when you give input to any system, it will use output, and meanwhile you will be having the losses. So we have to we have to subtract the losses, right? We have to subtract the losses, then only we can get the outputs. So that's why we are getting the 5% of less over here for the SMES, and we have the 90% of 10% of lesser in the supercapacitors and batteries, right? We have the 60% of lesser in the TES, that is thermal energy storage. So all right, so we'll see about the how this efficiency will matters in the power density as well as energy densities. So all right, so efficiency is nothing but what actually output to the inputs. All right, let us consider we have the PV cells, right? This is the photovoltaic module cells. All right, and this is your loads. Okay, so this is the PV cells, or this is your the grids. Just consider this is your solar panels or PV modules or solar grids. All right, and this is your loads, right? So what we are going to do to find the efficiency, right? The efficiency will always depends upon the output parameter and the input parameters what we provide, right? So how much of power it is given generated, how much of power it is stored in the batteries, how much of power it is being delivered from battery to the loads, right? So during that time some losses will occur, right? So that losses has to be considered for the efficiency purpose. All right, so to find out the efficiency we have to see how much of losses can be occurred, right? How much of losses can be occurred during the power delivery from the source to the loads. All right, so let us see if we have connected some the your PV cells to the directly to the loads. All right, we have connected the this solar panels. All right, the solar panels which is connected to the loads. So all right, so in this we have the batteries which makes a gap between the your PV panels as well as the load. So all right, so let us consider there is a batteries over here, right? We'll connect the batteries. All right, we'll see how the efficiency will matters over here, right? How the efficiency will matters and how energy losses will take place from the batteries to the loads. All right, how much of efficiency it will provides, right? The solar panel will provide a very lesser efficiency. When we compare, we are just talking about the energy storage. Don't bother about the solar efficiency, right? We have to think about the batteries, right? We have been energy storage. We are making the energy storage from the your renewable energies, right? So let us consider the WHP is the watt hour. That is the insolations, right? That is the irradiations. The irradiations which is coming from the what to say from the solar All right. Okay. Are you following, Mamta? Okay, Salman. All right, Sanjita. Sanjita S. Okay, Rashmi.
Yes, sir.
All right, no problems. So I'll be explaining in shortly. All right. Just give me for 2 to 3 minutes of time. Okay. Okay. You have any queries to this in the previous concept of power density and energy density? Is it clear?
Yes, sir. Importance
Your voice is not very clear, Vijay. There is a disturbance with your voice.
so main focus ಏನ್ ಮಾಡ್ಬೇಕು ಸರ್ ಇಷ್ಟು
You are focusing on
ಇಷ್ಟು ಟಾಪಿಕ್ ಅಲ್ಲಿ ಈಗ ಎಕ್ಸಾಮ್ ಪರ್ಪಸ್ ಮತ್ತೆ ಏನ್ ಫೋಕಸ್ ಮಾಡ್ಬೇಕು ಸರ್ ಇದರಲ್ಲಿ ಮೇನ್
ಇದರಲ್ಲಿ ಜಾಸ್ತಿ ಫೋಕಸ್ ಮಾಡಬೇಕಾಗಿರೋದು ನೀವು ಸ್ಟೋರೇಜ್ ಅಂಡ್ ಅಲ್ಟ್ರಾ ಕೆಪಾಸಿಟರ್ಸ್. ದಟ್ ಈಸ್ ವಾಟ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಮೇಕ್ ದ ಪಿ ಬಿ ಎಲ್, ರೈಟ್? ಪಿ ಬಿ ಎಲ್ ಅಲ್ಲಿ ನಿಮಗೆ ಐ ವಿಲ್ ಗಿವ್ ದ ಅಸೈನ್ಮೆಂಟ್ಸ್. ಇಟ್ ವಿಲ್ ಗಿವ್ಸ್ ಎ ವೆರಿ ಕ್ಲಿಯರ್ ಪಿಕ್ಚರ್, ರೈಟ್? For that we need to think how to can be designed for the ultra capacitors to have the more power density as well as the energy densities, right? How it will make the impact in the renewable energies, right? We have to focus more on the power density as well as the energy density to keep in a very peak way. ಎರಡು ಕೂಡ ಏನಾಗಬೇಕು, ಜಾಸ್ತಿ ಇದರಲ್ಲಿ ಇರಬೇಕು. ನಮಗೆ ಪವರ್ ಡೆನ್ಸಿಟಿನೂ ಬೇಕು, ನಮಗೆ ಎನರ್ಜಿ ಡೆನ್ಸಿಟಿ ಕೂಡ ಬೇಕು. ಒಂದು ಎನರ್ಜಿ ಡೆನ್ಸಿಟಿ ಒಂದ್ಸಲ ಕಡಿಮೆ ಆದರೆ ಪವರ್ ಡೆನ್ಸಿಟಿ ಕೂಡ ಜಾಸ್ತಿ ಆಗುತ್ತೆ, ಪವರ್ ಡೆನ್ಸಿಟಿ ಕಡಿಮೆ ಆದರೆ ಎನರ್ಜಿ ಡೆನ್ಸಿಟಿ ಕೂಡ ಜಾಸ್ತಿ ಆಗ್ತದೆ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ದ ಟೂ ಥಿಂಗ್ಸ್. ಆಲ್ ರೈಟ್, ದಟ್ ಈಸ್ ದ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ದ ಒಂದು ಬ್ಯಾಟ್ರಿ ತೊಗೊಂಡ್ರೆ ಅದರಲ್ಲಿ ಏನಾಗುತ್ತೆ ನಿಮಗೆ ಎನರ್ಜಿ ಡೆನ್ಸಿಟಿ ಜಾಸ್ತಿ ಬರ್ತಾ ಇದೆ, ಪವರ್ ಕಡಿಮೆ ಇದೆ. ಕರೆಕ್ಟ್. ಬ್ಯಾಟ್ರಿ ತುಂಬ ಟೈಮ್ ತೊಗೊಳುತ್ತೆ ಡಿಸ್ಚಾರ್ಜ್ ಮಾಡಲಿಕ್ಕೆ, ಆ್ಯಂಡ್ ಇಟ್ ವಿಲ್ ಟೇಕ್ ಎ ಲಾಂಗರ್ ಟೈಮ್ ಟು ಚಾರ್ಜ್ ಅಂಡ್ ಡಿಸ್ಚಾರ್ಜ್. ಬಟ್ ಪವರ್ ಡೆನ್ಸಿ ವೆನ್ ಯು ಟಾಕ್ ಅಬೌಟ್ ದಿ ಕೆಪಾಸಿಟರ್ಸ್, ಪವರ್ ಡೆನ್ಸಿಟಿ ಜಾಸ್ತಿ ಇರ್ತದೆ, ಬೇಗನೆ ಡಿಸ್ಚಾರ್ಜ್ ಮಾಡಿಬಿಡ್ತದೆ ಆ್ಯಂಡ್ ಬೇಗನೆ ಚಾರ್ಜ್ ಆಗುತ್ತೆ. ಸೊ ಇವೆರಡು ಅಟ್ ಎ ಟೈಮ್ ಬರಬೇಕಂದ್ರೆ ವಿ ಹ್ಯಾವ್ ಟು ಫೋಕಸ್ ಮೋರ್ ಆನ್ ದಿ ಸೂಪರ್ ಕೆಪಾಸಿಟರ್ಸ್. ಸೊ ದಟ್ ಈಸ್ ವಾಟ್ ಐ ಟೋಲ್ಡ್ ಇನ್ ದ ಸೂಪರ್ ಕೆಪಾಸಿಟರ್, ಫೋಕಸ್ ಮೋರ್ ಆನ್ ದಿ ಸೂಪರ್ ಕೆಪಾಸಿಟರ್. ಯಾಕಂದರೆ ಮುಂದೆ ನಾವೆಲ್ಲ ಫ್ಯೂಚರಲ್ಲಿ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಫಾರ್ ದಿ ಅಲ್ಟ್ರಾ ಕೆಪಾಸಿಟರ್ ಫಾರ್ ದ ವೆಹಿಕಲ್ಸ್. ಸರ್ ಇ ವಿ ವೆಹಿಕಲ್ಸಲ್ಲಿ ನಾವೆಲ್ಲ ಯೂಶ್ವಲಿ ಫಾರ್ ವೆನ್ ಯು ಟಾಕ್ ಅಬೌಟ್ ದ ಟಾಯ್ಸ್ ಆಫ್ ಯುವರ್ ಕಿಡ್ಸ್ ಎಲ್ಲ ವೆಹಿಕಲ್ಸ್ ಯೂಸ್ ಮಾಡ್ತಾರೆ, ಎಲೆಕ್ಟ್ರಿಕ್ ವೆಹಿಕಲ್ಸ್, ದ ಕಿಡ್ಸ್ ಟೈಪ್. ಅಲ್ಲೆಲ್ಲ ನಾವು ಏನು ಮಾಡ್ತೀವಿ, ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಯೂಸ್ the kind of the ultra capacitors, right, where it will make a quick start, right? So only for the starting purpose we are using the ultra capacitors, but not for the longevity of the EVs to deliver the power to the from battery to the loads. All right, so that's why we focus more on the ultra capacitors. So ultra capacitors, the design of the ultra capacitor, its characteristics, right, with the efficiency, and more efficiency we have to see the how efficient it is there for the providing the its energy, right, and the power also to the load from the batteries to the loads, right? So think more about the capacitors. That is capacitor, we require the both I'm talking about the ultra capacitors, right? You require the more energy, more power and more efficiency, right? In the previous slides I have shown very clearly that most of the energies, we don't talk about the most of the energies. All right, so here we have, I'll show you from the earlier, right? So if you see in the future days, right, future days we are looking for the hybrid storage. Correct. We use the multi technologies, integrate the both the parameters, that is the power and the energy. We require the power, we require the energy, we require the power density, we require the energy density, right, in a single systems, right? In a single systems we require the both. All right, so both is very very essential. We have to think about the hybrid storage systems. Uday, please focus on the hybrid storage. Is it clear, Uday?
Yes, sir. Yes.
Okay, we should think about the fabrications of the cells, right? How cells it will try to deliver both the parameters. Think about the capacitors, right? Think about the capacitors. Think about the super capacitors. How we can have the both the parameters at a time. Power should be high and energy density should be high. So that's why we are using in different applications. So if we see the capacitor, we are using in the grids, isn't it? We are using the grids. So whereas in the batteries, whereas in the EVs we are using the lithium ion batteries, right, where it has a low power and high energy. Whereas in the grids we are using the high power and the low energy, right? So both has to be integrated at a time and combine both to get the multi technologies, right, integrations for both the strength we can have at a time. So kindly I request you to focus more on the hybrid storage. Okay, so hybrid storage is very important. I hope it is clear. Uday, it is clear to you?
Yes, sir. Clear, sir.
Okay, along with this we'll see the efficiency, right? I was talking about the efficiencies, right? See, we have the PV panels, right? We have the PV panels, and we have the load also, right? We have the loads and we have the PV panels, where we have to think about the efficiency, right? If we want to deliver the maximum power, right? If we want to deliver the maximum power, we talk about the source as well as the load side, right? Now we have to think about the efficiency in terms of with this system in the renewable energy, right? With respect to the batteries, right? So batteries, how efficient it is there, how efficient it can work, what is the performance of the batteries, right? How much of losses it is giving, how much of losses it will occur during the time of charging and during the time of the discharging, how the chemical reaction will take place, right? In the especially in the batteries, how the conversions will happen, right? How much of losses will take place. That is what we have to focus more on the efficiency, especially in the grid side, in the renewable energy side, in the integrations of your renewable energy, right? So let us see the this is solar panels, right, where the radiations will fall on this. We call it as insolations, or we call it as irradiations, right? We say it is a whenever the radiation falls will hit on this the solar panels, right, the energy will be generated, right. The photovoltaic cells will try to emit the electrons, and electric current will be produced, right, which is in the form of charges, right. The charges is going to get into the batteries, right, where the conversions of electrical to chemical will happen, right. During the time the losses will also occur, right. During this time, that is what we call it as a watt hour EC, that is a watt hour electrical to chemical conversions, right, electrical to chemical conversion, right. Some losses are taking place over here, right. The losses are there during the generation from this solar panel, where the electrons will emit, it will try to produce the current in the form of charges, that the charges which is stored in the batteries, right, where we are going to store the charges in the batteries. It has to convert, right. Electrical energy should be converted into chemical energy, right, and again the chemical energy should be converted back to the electrical energy, which should be given to the loads. So during this instance, there is some losses are taking place, correct. Some losses are there. If you see, there is a lot of losses, where the efficiency will matters a lot, right. Efficiency is a total output to the input, correct. What is the input actually? We are giving the input to the system, right. You are getting the output, and some losses is also there. So what is the losses over here during the conversions, right? During the conversions, we have the losses, that is the electrical to chemical conversions, right? Electrical to the chemical conversions, there is a losses it is occurring, right. Electrical to chemical conversions, there is a losses is going to occur. All right. So these losses, we have to see how the losses will affect, in the batteries and also to the loads, right. The battery storage during the conversions of from electrical to chemical, the losses will take place, that is WHEC, that is a watt hour electrical to chemical conversion, right. During that instant, when you convert from one form to another form, some losses will be there, right. That is what we have to think. The efficiency, when you talk about the efficiency, the losses will be there, right. So again, when the battery is converted back to the from charge to the chemical energy, it will be stored, right. So when you talk about this, right, again that is WH battery, right. The WH battery is nothing but the watt hour battery. So watt hour battery, how much of energy is going to be stored? So that is WHPV, that is the W watt hour photovoltaic cell. How much of power it is giving? How much of power it is giving minus of WHEC, that is the WHEC is nothing but the electrical to again electrical to chemical conversions, right. Electrical to chemical conversions, you have to subtract from this, right. That is what is you are getting from the solar panel, WHPV, right. WHPV minus WHEC, that is watt hour electrical to chemical conversion, right. When you subtract these two, you will get the WH battery. WH battery is equal to what? WHPV. That is a WHPV from the solar cells. From the solar cells, we are going to have the electrical energy, right? During the conversion, some losses are taking place, right? So that's why WHP total, WHP minus, right? During the time of conversion, that is a WHEC. If you subtract these two from the actual one, we will get the WH battery. That is WHVAT. The WHVAT is equal to what? Actually, WHPV minus WHEC. Correct. So after this, the battery which is going to be stored, right? Again, once you get the WHEC, again this WHEC is get converted back to the chemical energy to the electrical energy conversion, right? Chemical to electrical energy conversion. There also some losses it is occurring. You see, there is losses here also. You have the losses of during the conversion of energy, correct. During the conversion of energy, the losses is also occurring, right. Whenever the conversion happens from the one form to another form of energy, usually the losses will be there, right. So that losses will also impact on the efficiency, correct. So if I give money of 100 rupees, right. So how much you are going to use? 89 rupees or 80 rupees you are going to use, right. And you are returning me back of 10 rupees, and 10 rupees you are giving to someone inside. Means this is one of the things where you can understand the concept very clearly, right. Some of the you have to return me back exactly the 100 rupees. Like if I give 100 rupees, you cannot lend me back 100 rupees, right? Because you have been utilized, right? You have been utilized for other purpose, right? You are not giving the 100 rupees back exactly for me. Whatever I am giving, you are not giving, correct? Because you are spending that money to somebody else. So that is the reasons where the battery will during the conversion, right? During the conversions, the losses will be occurs. So that is what the conversions will also depends upon the efficiency, right? During the efficiency, the losses will occur. We have to see how much of losses is going to be have from the battery to the loads, right? The generation is if you see the generation, right? If you see the generation is almost in terms of 1000 watt per meter square, right? That is the insolation radiation, so that is 1000 watt, 800 watt per meter square. The how much of energy it is coming from the radiations, and solar cell is going to generate the power. Then the solar cell is giving the electrical charges to into the batteries. And during the conversions, the chemical reaction, the chemical conversions will happen, and during that time also losses will occur. Right? During this time the losses will occur. Again, the battery has to be stored in the form of the chemical energy. Then the chemical energy again it has to convert back to the electrical energy, right? So during the chemical to electrical conversion, again the losses will occur. That will be called as a WHCE, that is a watt hour chemical to electrical conversions. All right, then this will be discharged with the loads. You can see there is a WH battery minus WHC now, right? Here WH battery is equal to WHPV minus WHEC, where during again the conversion from the electrical conversion to the loads, we have the WH battery is equal to WH battery minus WHC. That is the battery total battery minus again the chemical to electrical conversion you have to subtract. So that much of energy is being given to the load, right? That is what the losses is. You can notice there is a losses in during the conversions, right? So efficiency is defined as what? Output power, right? What is output power actually? WH, correct? WH load, WH, that is a watt hour delivered to the loads. How much of watt hour is delivered to the load? To the WH drawn from the source. This is the WH which is drawn from the source, and how much of WH is going to the loads. So if you take this ratio, no, so you will get the actual efficiency. All right, this is the actual efficiency. How it is makes an impact on the efficiency for the energy storage. Correct. So if you see WH delivered to the load, right? So WH battery minus WH chemical to electrical conversions, right? Here already shown WH battery minus WH C. Correct. This is the output actually. This is the output, right? So WH battery minus WHC, that is watt hour chemical to electrical conversion, right? And WH drawn from this source is WHP. So WHP is nothing but this, so WHPV is nothing but this one, right? From the source it is delivering the around 1000 watt per meter square or 1200 watt per meter square. It depends upon the radiations of the sun, how much of insolation it is falling on the PV photovoltaic cells modules. But based on that, it will try to give the source, right? Which is drawn from the source. So, all right. I hope it is clear. Is it clear, Uday? Sneha?
Yes, sir.
Yes, sir.
Okay, let us see the scenario of the energy consumption, right, in the various sources and the international levels, right? Why we should go for, especially for the energy balancing in India, right? If you see in this graph from the since very long back from the 1980s, right, from the 19th centuries to 21st centuries, right? There is a drastic changes in the consumptions. If you see there is drastic changes in the consumption, there is more consumption, the production is very less. All right, consumption is more. So all the times you cannot have the life of your grids supply to the loads, right? Because as I told you, the partially may have the cloudy days, partially you may have the um, wind, right? Depending upon. That's why we are going for the integration, right? Integrations. That's why we are going to make the integration, and we are going to store the energy in the batteries, right? Because the people are using the lot of consumption is every day it is happening. Everyone wants to use their utilities, right? Everyone want to have the in the peak time. You cannot make the peak shavings, right? Because For that reason only we are going to for the energy storage. When we have the more energy consumptions, we have to think about the energy storage also. We have to balance the energy, that is supply and the demand. That is we have to balance. That is energy balance nothing but what? We have to balance the supply. We have to balance the demand also. Correct? So if the consumption is more, see day by day what is happening, consumption is rapidly it is going to be increased because the population densities. Because the more populations, the more consumption will happen, right? The more people are using, the more kinds of utilities, right? It may be of your electrical utilities, your geyser, washing machines, whatever it may be, right? Consumption is more because the more number of the what is the load is in the upcoming days we have the n number of loads, right? So you cannot have the generation cannot be decayed, it cannot be reduced. So all right, the consumption should be very high, right? It's better to go for the energy balancing, right? So that we have to go for the energy storage, right? When you go for the energy storage, it will be better to give the source. You can balance the energy as well as the demand at a time for the consumers, right? So production should be more rather than the consumptions, right? So for that only we are looking for the smart grids technologies, right? In the smart grid technology, it will become the vice versa. If you don't have a smart grids, no, this is what the problems we are facing in nowadays in India, right? Consumption is happening more, right? Everybody wants to use their consumptions, right? Everyone wants to have their usage, right? Everybody wants to use their all the devices at all the times, right? But nobody is going to see the power losses, the power wastage, right? During that time, what will happen? The production will also go very higher, correct? If you think about the production will also go very higher. It's all right. So because of this, we have to learn more about the energy storage, right? So what is the importance of this energy storage systems, right? If we first about the renewable energy sources, right? We have the variable outputs, right? We cannot have the constant outputs of all the time from the grids, right? That's why we have to focus more on the energy storage, right? And the battery storage, right? There is a variable output, so you cannot have the same output all the times. The radiations will not be there throughout the day same, right? It may have high radiations, it may have low radiations, right? Sometimes you may have the wind blowing will be very high, sometimes it will be very low. That's why the output is variables, right? If we make the integrations, we can compensate, right? We can compensate the energy storage, right? So we should have the energy buffering, right? We have to make the storage. Buffering key, get ready. Please get ready whenever there is a demand comes, right? Whenever the demand comes, you should have to supply immediately. So that's why you have to keep the buffer. There should be the buffer of energy in your grids, right? You cannot make the live generations. You cannot make the live supply. If you have the energy storage. At all the times we can keep the buffering of the energy storage, we can satisfy the load demands also, right? If you see, it is very important in the present scenario, right? In the present scenario, because of the rapidly growing of populations, rapidly usage of the appliances from the consumers, so we should have the energy buffer also, right? We should give the vital for the ESS, right? Vital means the important things, we have to give more importance on the energy storage system, right? And think about the new technologies, what you can build, what the new things you can build for, and what kind of devices you can bring. So that will matters a lot for the upcoming days, right? So these are the various things where you have to think about the energy storage, right? If we talk about the different types of energy storage, we have the mechanical storage, right? Magnetic storage, we have thermal and chemical, right? Chemical we already discussed with respect to the efficiency. So like this is how the mechanical energy storage will have, that is the flywheels, right? Energy stored in the form of mechanical energy. The diagram shows it's the very clear about the flywheels where you are going to store the energy in the form of mechanical energy, right? It is very light in weight, and the materials which are used is of the fiber materials, right? Which increases its efficiency because of the usage of these fiber materials. It is very light in weight, so that's why it is providing the more efficiency. And energy density, if we talk about the energy density, it is around 0.05 megajoules to per kg, and also kilograms. Efficiency, when you talk about efficiency, it is almost, it is good in nature. The energy density with respect to efficiency is 0.8, right? So this is energy density, which is defined as energy per unit mass, right? So EV is equal to half mv square, right? If we take the EV, if we take the m over here in the denominator, right? This EV is equal to half times of mv. So m is the mass, and v is the velocity of the flywheels, where it is going to get the mechanical energy to generate the store the mechanical energy, right? M is the mass of the particular system, right? V is the velocity of the flywheels, right? Sigma is the specific strength of that composite materials, and rho is the density of that materials, right? Based on that materials, we can calculate the energy densities, right? Using the half mv square equations, right? So here we are writing E by m, right? E by m, and nothing but the which is analogous to the sigma, and which is analogous to the density of that materials, right? The mass are nothing but the density of the materials, how we are going to utilize it, right? So these are the various materials for building up flywheels, right? If you take the material for steel, the density will be 7,800 kg per meter cubes. If you use the aluminum, that is 2,700. If you use the titanium, it is 4,500 kg per meter cube, right? If you use the carbon fiber reinforced, it is 1,500. If you see the strength of that materials, right? The specific strength for the steel, it is 0.22. For aluminum, it is 0.2, almost same. It is for glass fiber reinforced, it is around 0.80, and for carbon fiber reinforced, it is around 1.60. What is the benefit of this from this? What is the advantage? What is the merits and demerits? If you see, it is very compact, right? If you see this design, flywheels, it looks very compact, where you are going to store your energy in the mechanical form, right? And compared with the other energy storage, right? If you see, the flywheels are used for the starting, and especially in the locomotives, nothing but the trains, electric Indian trains, Indian railways, where they are going to use the for the studying purpose of your electric trains, right? Because it requires the mechanical energy, which is stored in the flywheels for the initiating the initial start of your all the locomotive vehicles, that nothing but the trains, right? The flywheels is preferred due to the lightweight and also high energy density, right? Density, when you talk about the density, it depends upon the types of materials which have been used for the specific for the design. All right, based on this composite materials, the density will also will gives a lot of impact on the types of the materials which has been used. All right, so the flywheel is preferred to the lightweight and high energy density capacity. It is not economical, as it is had to be limited amount of charge and discharge of cycle will be there. That is what we are about the we are talking about the charge and discharge of life cycles, right? It is how much it will charge, how much it will. That is called the life cycle of that system, right? Life cycle of that life cycle of that materials, right? So this is one of the compressed air storage, right, where you can have the underground of the air storage, right? So how the air will be stored in the beneath the surface of the earth, right, where you are going to store the energy, right? Right. Let us see the this operations during the off-peak electricity to compress the air and stored in the airtight underground or caverns, right? So during the off-peak time electricities, where the usage is very less, right? You can store the energy, that is air energy, right? That is energy can store in the beneath the earth, right? You require the lot of bigger the containers or bigger volume of the containers, where you can to under the ground, underground where you can going to store the compressed air, right? And it is stored in the very tight, right? When the air is released from the storage, it expands to the combustion turbines and create electricity, right? It is going to, when it is pumped from this, right, from the chamber of the through the compressor, right? It is compressed air is pumped back, and it is given to the your turbines, right? It is given to the these turbines, and turbines will try to rotate, and in terms it is connected to the synchronous generators, where it is going to generate from these prime movers, that is the turbines, to the generators, where it is going to generate the power. Then it will be transferred to the transmission lines, and then to the loads, right? Where this turbines also required, maybe of your kinds of the IC engines or any kind of the prime movers, all right? So that is what the heat exchanger, right? The heat exchanger also they have been used for the recuperator. The heat exchanger will be there because to stabilize the system, right? Or else it will get the more enormous of heat will be, thermal energy will be generated, because we are taking the compressed air and it passing to the turbines, and turbines will try to hit the air will be hit by these turbines, and will try to generate the energy in the synchronous generators, where it will be power will be transmitted to a very long distance, right, in the transmission lines. Right? This is one form of the energy storage, right? Uh, so this advantage is the first setup, right? And the drawback is the structure of resilience is also very important, right? Geological structure is also very matters. It depends upon the type of the soils, the type of the area you are going to use for the storage. So we have a lot of drawbacks for the storage also, all right? So when you talk about the supercapacitors, right? Is it clear, Uday, Sneha, Mamta?
Yes, there is.
Yes, sir.
All right, when you talk about a supercapacitor, right? Supercapacitor also kind of the our electronic device. The capacity will provide the high power, right? As already told, this word is very important, right? High power and the energy, and high energy and high power. That is what we are focusing more on, the ultra capacitors. Supercapacitor is also called as ultra capacitor, right? High power and high energy, which has the characteristics of capacitor and electrochemical batteries also. And there is, we don't find any like chemical reactions with it, right? There is no chemical reactions. It is a double layers. You can see there is a two layers, right? We have the carbon electrodes for here, and we also the carbon electrodes for here, right? And two terms are taken out, and we have in the inner layer, in the mid layers, we have the capacitor, that is we call it as a double layer capacitor, right? You can see there is a positive charge over here and negative charge over here, and here positive charge, alternately the positive negative and positive negative, right? So during the electrolysis process, what will happen? It will try to recombine the charges to generate the energy more faster, right? It will try to generate the energy and the power densities in a very quicker way, right? And it will try to release the and absorption and release of the energy and power also, it is very high. So that's why we prefer the electronic devices, its capacity to provide the high power and high densities also. So that's why we look for the ultra capacitors, especially in the grids, in power systems, right? Where these characteristics of the capacitors and electrochemical batteries, except we don't have any kind of there is no chemical reactions, right? It is not converting your electrical energy into chemical energy to the electrical energy like your batteries, right? It is also the simple way. The working principle is also very simple. I try to provide the recombine of the charges to create the moment of inertia of the charges, where it is going to create the more energy and more power, right? And for the lesser time, right? For the lesser time, it will try to create the more power and more energy. So that's why we prefer in the grids, right? What is the benefit from this? Virtual unlimited life cycles, right? If you see the virtually the unlimited life cycle, the charging and discharging, right? We cannot make the predictions, right? So charging is nothing but how fast it will charge, how fast it will discharge, right? For example, if it is a life cycle is around 2000, if we take life cycle is 2000, right? If I say 2000 or 3000 life cycle, what does it mean actually? Sir, the battery have 2000 of life cycle, means it will discharge for 2000 time, or it will charge for 2000 time, then the life is gone. That is called life cycle. All right. So it will have the rapid charging, right? You can see there is a word called rapid, means fast. Fastly it will charge and fastly it will discharge, right? So it depends upon the type of the super capacitors that you have been used, right? Sometimes it may be more faster, or sometimes it may have the the unlimited life cycles also, like 2000, 5000. 5000 means it will charge for 5000 times, and it will discharge for 5000 times. That is called the life cycles. Means it is giving its life, right? After that, you cannot have to reuse that one. All right. So that is what the life cycle will tell us, right? Actually, when you talk about the human being life, right? For 80 years, 60 years, 50 years, like this. Okay. So that is what it will have the benefit of the unlimited life cycles in the supercapacitor. Fast charging it is there, that is rapid charging, and impedance is very low as compared with the other things, right? And there is simple way of charging methods, right? You can see in the diagram that is recombining of the charges. What is the disadvantage? That is a low energy densities, right? We have to improve this. That is what I was talking about. We require high power and high density, right? So if you talk about the supercapacitor, the power density is very high. I can accept it, but very less energy density will be there. That is what we have to make the improvement in the for the supercapacitor for the increasing its energy densities, right? And cells may have the low voltage, right? It maybe have less value of the ratings of the voltage, right? And have a high self discharge. So that is a drawback. It will discharge very quickly, right? The self discharge is very quickly. If you connect to any device, it will discharge very quickly. That's why we have to think about the linear discharge, right? Voltage prevents the uses of the full energy the spectrum. We have to think about how linear discharge can be happen for the to prevent the voltage, right? For the full energy spectrums, right? So next is the superconducting magnetic energy, right? So this is another form of type of energy storage, right? So where we are going to use the let's see the diagram there. First we'll see the diagram. There are three components, right? We have the power system, we have power conditioning system, we have superconducting coils, we have refrigeration system. All right. So these are the three major components in the superconducting magnetic energy storage, right? So energy stored in the form of magnetic fields, right? It tells about the superconducting. We have the superconducting coils, correct? In the superconducting coils, we are going to store the magnetic energy, all right? So if you want to take, you can take the screenshot of this to make it understand very clearly. All right, if you want to take the screenshot, you can take. So they are following Uday, Sneha, Mamta, Shivraj.
Yes, sir.
Okay, all right. I told you please be attentive. Okay. Anyhow, we are going to make a record of your these sessions. Okay, you can have in the live videos in the now, and you can have the videos in the YouTube also. All right. So there is no issue. Again, you can watch back it again. No problem. But try to concentrate as much as possible. So, all right. So we are discussing about the components of superconducting magnetic materials. All right. Just 2 minutes, okay? I'll be back. 2 minutes. Okay, all right. I'm audible, Uday?
Yes, sir. Audible.
Yeah. Actually, we are discussing about the SMEs, right? Superconducting magnetic energy storage, right? So this try to store the energy in the form of mechanical energy, in the form of magnetic fields, right? The system consists of the three major components. That is, we have the superconducting coil, we have the power conditioning system, and the cooling system. Nothing but the refrigerators, right? So here you can see there is a different forms of systems we have. That is three components we have. That is a power system, power conditioning system, superconducting system, and refrigeration, then the cooling system, right? So if you see the three components which tells about the one is a coil, power conditioning system, and cooling system, right? The our idea is to keep store the energy in the form of electromagnetic field, right? It is just like how do you store the energy in the inductors, right? Inductor, we are going to store the energy in the form of magnetic fields, right? The same concept they have been implemented in the, if you see in the capacitors, we are going to store them in the form of electrical charges, right? And the inductor, we are going to store the in the form of magnetic fields. Similarly, same concept they have been utilized. The idea is very simple: to store the energy, right? Finally, we have to store the energy in the form of electromagnetic fields, right? So which is surrounding the coils, which is made up of the superconductor, right? This is actually your superconductor coils, right? So that's why it will store, it will be in the form of coil. You can see it is in the form of coils, where it is going to store the entire your electromagnetic fields, right? For the later use, which can get convert from electric to magnetic fields. Similar, just like inductors only, right? So when there is a heated up, the cooling system will also comes into the picture. All right. So here at very low, if you see the at very low temperature, some material loses its electric resistance, right? And thus become the superconducting. So when you talk about the any materials which lost its resistance, it will go to the negative temperature, right? Negative resistance temperature it will go. So based with that is one advantage where you can have the storage that will make use of this phenomena to store the energy without almost any losses, right? Practically you can have the efficiency of 90 to 95%, but make the materials to store the sorry, to make the materials to be in the resistance to go very low, at the low temperature only, right? The materials has to lose its electric resistance, and it has to become completely the superconducting materials. Then only it will try to store the energy in the form of electromagnetic, right? So at efficiency is almost around 90 to 95% of efficiency it will give, right? So since it is very relevant, superconducting materials are known to work below minus 255 degree, nothing but 20 Kelvin 20 degree Kelvins, right? The materials which are used, that is niobium and titanium, that is 264 degrees centigrade, right, and 9 degree Kelvin. Niobium tin, we are having the 20 to 55 degree minus 255 degrees centigrade. Means the material has to go to the negative temperature. Then only it is possible to make the superconducting materials. And the system, we have the system to pull the various components to down the temperature which is required for the rated levels of the temperature to make the conducting materials to become the more superconducting also, right? So this can be done by the liquefying the helium, right? But it is very expensive in case of other materials, and that's the process of these are the lower the efficiency. That's why especially we stand by the other modes of the generation for storing the energies, right? So this is actually the system. What are the benefits from this? Power is available almost instantly. Whenever you want the power, you can just convert your magnetic field to electric field back to magnetic field, right? That is what the benefit from this, right? Superconducting magnetic storage will help us to store the energy in the form of magnetic field, right? So that is electromagnetic field is available all the times. Whenever it is required, it will try to convert, right, from electric field to the magnetic field, right? And output is almost, it is very higher, right, for a long time, right? And there is no power loss, and also there is no kind of the moving part where there is no any rotating part also we don't have any like kind of the rotating parts, right? And response time is very quicker. So these are the very benefits as compared with the other types of the storage, right? And when you come to the point of disadvantages, right? Disadvantages will tell us about the energy content is small and the short life. Means the energy will be storage will be very less, but it may have instantly it will provide the energy, but the with very short time, right? And it will works with the cold temperature, right? It will works with the cold temperature technology, and that is one of the most challenging, right? We have to make the materials to behave as a superconductor, or else it will doesn't work for you. So that is the one thing where you have to see the materials should go to the lowest temperature, right? And energy losses will be very less as compared with the other materials. So, all right. So high energy losses will be there. It is very expensive in the production and other maintenance also. We have to maintain this one at all the times because we have to maintain the temperature of minus 3 degrees centigrades, right? Or else it doesn't work on the materials will not go to the lowest resistance and at the required temperature of negative minus centigrades. So that is the reasons. So we have to think about the cold temperature technologies. That is the most challenging, right? Cryogenic will tell us about the lowest temperature, where it's related with the lowest temperature technologies we have to implement. So that is the main drawbacks for this kind of the storage, right? Because material bring that material to the superconducting, right? And also bring to the very lowest temperature. The cryogenic is nothing but where we have to make that materials to work at the very low temperature. So that is one of the challenging nowadays, right? So these are the various advantages and disadvantages. Pump storage, we have the pump storage also, right? It consists of the two reservoirs and where it is located at the different elevators, right? So one is to bring the water to the from the main side from the search chambers where it will try to hit the your turbines, right? And another we have the another kind of the system where the water is gets pumped back in the reservoirs to the elevators, right? So during the peak demand, the water is released from the upper reservoirs, right? When there is peak demand, the water we are going to release from the upper reservoir, the production exceeds the demand, right? If the production which exceeds the demand, the water pumped from and stored in the upper reservoirs. If the demand is very high, the production will also exceeds. That is what we have to store the energy in the upper reservoirs. Here you can see there is a reservoir the switchyards where you are going to store your hydro energy, that is water you are going to store it, right? So here the pump is used to combine motor and dynamo, right? We have the pumping systems where we are make the combinations of the pump as well as the motor as well as the dynamo. Right, the benefit from this, it is one of the most effective way to generate the electricity, right? In terms of megawatt also you can generate. This is one of the best form of energy generation. That is a hydro pump, hydro storage energy is also very good one. During the peak and also the energy densities as compared, as I told, energy density is also around 2000 megawatt you can generate. In terms of efficiency, almost it is a zero point 0.8. Depends upon the all the geographical parameters, right? About the type of the layers of the soils that you are going to use, a black soil, red soil, everything will depends the geographical natures. The capital cost is very massive because you have to build the construction of this plant is very difficult. You have to purchase the land, either you have to take from the we have to government has to purchase the lands. So that's why it is very cost effective. You have to bring all the kinds of the various components to produce produce electricities, and also you have to make the storage systems also. That's why it is very cost is very massive, right? And the soil erosions and other things, slitting of dams, we have to take care of this. So these are the various drawbacks. You have to test the soils, then you have to go for the purchasing the lands for that one, right? So this is actually capacity we already discussed, right? And this is a comparison between the various batteries energy storage, right? That's a specific energy, specific power life cycles. As I told, the life cycle of the batteries, it may be of a lithium-ion batteries 1000 to 10,000, right? It tells about actually the charging and discharging time. If it is charged for 1000 times, then the life is gone. If it is discharged for 10,000 times, then the life is gone. After beyond that, it will not work only. So that is called the life cycle. Life cycle will tells about the what is the how many years it may come. It may come for 2 years. It may come for 4 years. It may come for 5 years. It may come for 10 years. So that is called the life cycle. How much it will charge and how much it will discharge, right? So that is called the life cycle. And then when you talk about the power, if you for the your lithium ions, it is around 200 to 315, right? And charging discharging efficiency is around 95%. And for lead acid is 80%. For nickel cadmium it is 70%. For sodium sulfur it is up to 90%, right? Self discharge, right? These are the in terms of percentage with respect to the per month, right? And the sodium sulfur we don't have any kind of the self discharge, where lithium will have the 1%, and self discharge by itself, that is it is going to be discharged by itself only, right? And just like your ultra capacitors, right? So percent is very less when you compare with this, right? So that's why when you talk about the lithium ion batteries, that it is almost like 1% per month it is there. So that's why it is very highest in terms of charge and discharge energy efficiency. It is 95%, right? Percentage is also very less. It is 1% of self discharge. If you see the 80% of the self discharge energy efficiency, the self discharge is going to be around 5%. All right. So these are the various things, right? And these are applications of the thermal energy storage. So, all right, when you talk about the which is a better, right? We should think about the different way of the energy storage. The reason is that we have to think about the storage methods in the different capacity range and the maximal usage of that storage time, right? These are the things we have to look after. Superconducting can store energy with the negligible losses. Right, fuel cells also we have, that is alternate for the petrol engines due to the high efficiency, right? Flywheels also we have with a narrow range and not for answer for longer scale of operations, right? When you talk about the when you talk about the conclusions, right, of this energy storage, right? The reliable and the more affordable energy storage is a prerequisite for using renewable energy, right? We have to think about the reliabilities and energy affordable means how much of energy it can store for a longevity, its life cycles, its discharge time, its efficiency, its power, its energy density, all things we have to look after, right? So energy storage will plays a very vital role in the future days, also in our coming days, right? So we have to think about the various technologies which is currently available to meet all these our increasing demand of energies, right? We have to think about the power demands, we have to think about the supply demands, we have to think about the storage. We have to bring the new technology for the energy storage in the upcoming days. All right. So why energy storage is required? Because of this peak shaving, right? We have to cut the loads, right? We have to cut the loads during time of the peak hours. Then you can supply from your batteries also during that time when there is no generations. All right. And these are the various things: electricity and the electricity price also. And for the RSA renewable energy integrations also, we are using the energy storage for the batteries. Um, this is the energy storage in the renewable source integration, right? So there is an intermittent of renewable. You cannot have the continuity of the generation. You see, there is a no generation over here, right? From the since from certain hours, and again we have the generation. Again we have the generation. Again there is no generation. So this is the reason we should go for the energy storage, right? We cannot have the continuous storage, right? If you see in the another graph with respect to this, there is a storage may be enormous sometimes due to the resources available, and sometimes resource may have the continuity of the resources will be there, either radiations or either the wind, right? So that is the intermittency of the renewable energy sources. That's why you should go for the storage. So that if you store, there will be reliability of your energy power dispatch to the load. So right, this is what how the intermittency of the renewable energy sources will happens, right? So if you see from the with respect to the 4 a.m. and 8 a.m. and the 4 p.m. and 8 p.m., right? So 8 a.m. to 4 a.m. Almost there is a drop in the car without the storage of flexible and also with the storage providing the flexible time during this time. The most of the energy will not be utilized, so you can go for the storage purpose. We can store the energy in the form of in the town the to deliver the loads. We can store the energy in the form of 3 megawatts, right? When there is a off peak, when there is a off peak, you can there is a when there is a off peaks, you can store the energy, right? So that is how the curve actually tells about. Right, this is the energy for the load leveling, right? So this is with respect to the power in the terms of megawatts during the base load with storage and the base load without the storage. Right, we have to store the energy during this time. The power generated required without the energy storage and the energy power which is required with respect to the energy storage. That is what you have to balance the loads. Right, whenever the load comes, you have to provide the actual energy from the energy storage to meet the load levelings, right? If you see here there is a charge from the grids and there is a discharge from the into the grids, right? Here the battery is getting to be charged. This is how the curve will actually comes for the load leveling, right? So these are the various applications of the energy storage, right? As I told, it is support for the grids, right? In the transmission distribution, right? It will make the system to be the more stable, right? In renewable energy integrations also, time shifting, capacity forming, and also grid integrations also, it will help us to make the system to be more stability, right? So these are the various applications, and also during the customer energy management service also, it will help us to give the power qualities and reliabilities for the customers. The peak shaving also it will provide. So these are the various applications for the energy storage, right? Energy storage in the current and the future status you can see with respect to the global cumulative energy storage installations, right? So from the since 2010 it is a drastically increasing because of the production, because of the consumption of the energies, right? So we should think about the in the megawatt. Earlier we are thinking about the megawatt over here, right? Now we have to think about in terms of the gigawatt. How various countries are going for the, you can see in this curve, there are various countries are going to have their energy storage for the future usage also, in the future trend also, because we require the more usage, right? We are not going to nowadays we are not going to store the energy, but present technologies we are going to make that kinds of the storages where it is may use for the future, right? If we see India, Germany, United States, and China, all are going to be have the more enormous of terms of in terms of gigawatt only they are going. Everyone is going for the storage in the terms of the gigawatt, right? It is rapidly, it is going to be increased in the year 2040, right? So it will keep on increases. The storage will also keep on from the various countries we are going to store the energy. Right, this is actually application of your energy storage in the grids, right, where you are going to provide the reactive power, as I already explained. Uday, it is visible now.
Yes, sir. Visible.
As I've discussed about the reactive power, no, this is the actually in the power system, right? So where you are
Ah,
going to inject the reactive power to the in the system, right, from the energy storage, like from the your capacitors, right? This is actually the diagram where you are going to make the stability of your power systems to providing the reactive power compensations. So all right, so we are at the end stage now. Some of the storages can act virtually inertia because of the in the microgrids to have to enhance the frequency stabilities also, right? Some energy storage with a very fast response, right? Battery energy storage, the supercapacitors, the flywheels, and also the various things we already discussed, right? So I'm going to share the applications of integrations, right? Is it visible?
no, sir.
Uh, yes, whether it is visible to you know.
No, sir. No. It's visible only components of superconductor.
Okay, no problem. So it will go to the applications like because in the syllabus they may ask you in the exams the applications of your energy storage in the renewable energy integrations, right? What are the application of energy storage? How it is utilized for the electric vehicles and also in the microgrids also. All right. So what are the applications from the energy storage from the two grids, that is the renewable of your solar as well as the wind energy, right? By integrating how we can it can be applied to the various applications, right? Especially we already know it from the grid. We can make the V2G also, that is vehicle to grid also it is possible. From the grid to the vehicle is also possible if you store the energy, right? So let us see how this will makes a lot of impact, right? So EV charging also it is very very important in the EV charging using the solar energy, right? So nowadays the people are using the EV vehicles, right, to charge their vehicles. They are using the solar PV modules, right? Solar panels will try to generate the energy during the day times, and energy will be storage in the batteries, right, to store the excess of energy that can be used for the EV charging also, right? So from the solar panel only we are going to generate the electricity and it will be stored in the batteries for the electric and the excess of power. It can be charged you during the night time also during the cloudy conditions, right? So this is one of the application for the energy storage. All right. So next, what are the advantage? It reduces the electricity bills, right? You cannot have the charging during the without having any battery storage, right? So it will try to reduce your electricity bill also. It will decrease the dependency on the grid power. So if you have the storage, try to make the DC fast charging at your home only, right? If you have to keep the batteries and make the storage and make the charging for your electric vehicles also, right? So that you never depend upon the supply of the supply from the BESCOM or any people from the grid also, right? So it will promote the cleaner transportations. Also, it will help us to make the lot of benefits from this, right? So like this is the actual diagrams where you can make the solar panels, right, and make the battery storage, okay, then make the DC fast charging. So it will be very useful for, don't depend upon always the grids. This diagram will actually explains the how energy can be stored, how it can be utilized for your electric vehicles, right? Energy, battery energy storage for the your renewable energies, right? In the renewable energies, we are keeping the solar panels. We have the battery storage. Also, we have the from battery. We have the DC fast charging also systems have been employed, so that the we cannot depend upon the grids at all the times. All right. So you can see there is a we can you need not to depend upon the grids. Right? Don't depend upon the grids always. It will try to reduce your dependency on the grid power also. So that is the one thing, so you can make use of these kinds of the systems, right, for the energy storage. All right, you can see in this diagram also we have the solar panels, right, where the battery energy storage also it is there, and the DC power which is coming and it is sent back to the it is given it is sent back, it is stored in the batteries, right? It is used for the energy management, then it is going for your DC fast charging also, right? So these are the applications for your integration of your grids with either it may be solar or wind or alone only with solar panels to store the battery energies, right? So for grid stabilization, when you talk about the grid stabilizations, we have the large number of EV charging which is simultaneously can create the heavy load on the electrical grids, right? So to make the stability, we have to make the load balancing also. So for that redundancy, we have to balance the supply and demand. So that is what we have discussed in the very most first class, right? So what is the function is to store the energy during the load demands, and also we have to supply the energy during the peak demands. So that is one of the functions where we make the grid stabilization, right? Wherever the load is not, wherever the grid is becoming instability, so make use of your energy storage to make the stability of the grids in a very easier way, right? So it help us to make the grid reliability also, right? It makes the system to be more reliable, right? That is one of the applications. It is also used in the fast charging also, right? You can have the fast charging. This is one of the application for the from the your energy storage for the renewable energy, right? Fast charging also requires a high power for short duration, right? Where you can use your DC fast charging to store the energy from the grid, that from the grid to the EV chargers, where you can make the your electric vehicle or heavy electric vehicle also you can charge, right? This is a benefit. What is the benefit from this from fast charging? It will help us to charge very quickly also, right? And also it will make improve our charging efficiency also if you make a fast charging station, right? Here you can see there is a lot of batteries we have. This is the BSS, that is the battery energy storage, right? So from the grids we are going to store all the energies, then it is given to the DC to the your heavy electric vehicles, right? So this is one of the images where India has been have the ultra fast DC chargers. Right, this is actually the vehicle to grid technologies, where from the vehicle to grid we are going to give the energy. Right, battery acts like a mobile energy for the storage units. Right, so EV stores the energy during the charging, and also it will supplies energy back to the grids. That is when there is a peak demand, it will try to supply the energy back to the grids when there is a peak demands. So all right, next we have the wind energy integration with the EV charging also. This is actually images and the backup powers, right? This is actually the backup powers for the emergency supply. Energy storage will help us to provide the backup power during the grid failures, right? When there is a grid failure, when there is no generations, you anyhow stored the power in terms of the gigawatt. Now you can supply easily for the consumers also when there is a blackout or when there is a grid failure also. That is one of the benefit applications of your energy storage. So these are the various applications, all right. So make use of this, and type of the energy storage which are used. We are using the capacitors, we are using the lithium ion batteries, we are using the flywheels, and we are using the pump hydros also, right? So these are the, as I told, for the lithium ion batteries, especially it is used in the EV batteries and charging station, right? Super capacitor, which are used for the fast charging and fast discharging, especially in the it is used in the charging support for the in the power grid also, right? So these are the various applications where you can go through this, all right? So these are the various applications, all right? So major applications of the energy storage in the renewable energy system for your EVs as well as the microgrids. So all right, so we'll see about the microgrids. So right, what is the purpose of having these grids, and what are the components it consists of? What is the need of ESS? There's energy storage in the microgrids and energy storage technologies. Its benefit, and what are the ongoing projects, and what are the different types of future directions on the research which is happening in the microgrids. All right. So what is actually the microgrids? It's a group of interconnected loads and distributed energy resources within the clearly defined electrical boundaries. So that acts as a single controllable entity with respect to the grids, right? So in this image, you can see you can see the components of microgrids, right? We have the wind, we have the solar, we have like just like a small distributed generations, and we have the small load. we have the loads, we have the energy storage system also, we have controllers, we have switching devices, right? Where all the points has been coupled to each other to for the proper reliabilities of the power supply from the grid to the battery to the back converting to the by using controller conversions, as well as making the conversions controlling to the loads, right? So that is the reasons where we have to see more about the grids. All right. So how the grid is going to be operated. So let us see. This is actually your we have the wind turbines, right, where we are going to generate the power, right, and also after generation of power, it is given to the all the compressed your batteries for the storage, right. From the storage, we are giving the supply to the all the various systems, right. It is a small kind of the grids, where that's why it is called as a microgrids, right, where the controllers, you can see there is a controller also, as I told. In the controller we have the various controllers also. We have in the grids, we have the loads, we have the controllers, we have the static disconnecting switch, energy storage system, that is a battery, switching devices also we have, that is power electronic devices will be there for the switching. For converting and controlling, we require the power electronic switching devices, right. All these will be interconnected for the proper reliability purpose. All right. So what is actually a microgrid? It is connected to both the local generating units and the utility grids, right? So thus preventing the power outage. So if you see the microgrid, it is it's like a small grids where local generation will be there, and also the utility grids will be there, right? So it will try to avoid your blackouts and the power outage for the customer, for the consumers, right? Excess power can be sold to the utility grid also. So once you generate the power, you can sell to the your utility grids also, right? That is one of the benefits from the microgrids. You generate it and you sell it to the, for example, this Suzlon company we have, the where the solar the turbines, right, the wind turbines which is run by the Suzlon companies, they are also going to generate the power. They are also giving power to the government also, right? That means that the capital for the Bescoms and these suppliers, right, for making the distribution of the power, right. So microgrid will have the generation of its own, and you can sell the power to the utility grid also. And the size of the microgrid may range from the housing estate to the municipal region. It may be smaller to a little bigger size, right? So these are the attributes where you have to think about the grouping of all the loads and distributed energy sources for the grids, and can operate in the different modes, that is island modes or the grid connected modes, if whenever it is required, right. It acts like a single controllable to the grids, right. What is the purpose of grids? Why you have to, why we need to have the grids? Because transmission losses gets highly reduced, right. If you are generating from the, for example, you are generating from the Udupi, the power is coming from Udupi to Bangalore, right. We are transmitting very longer distance for more than 500 kilometers, right. During that time, the transmission losses will occur. You create a small grids, have the generations and the loads within your limit, right, so that the transmission losses can be reduced. So that is one of the benefit for the need of the microgrids, right. So and also microgrid will help us to make the sustainable sustainability. It will be very easier, and also cut emissions without any major challenge to the lifestyle, right. We can have the more continuity of the power, right. It provides the high qualities, and reliability of energy will be there at all the times to all critical loads. So right, so this is what actually I was discussing about how the grids will be connected, right? The point of the common coupling. This is the point of the actually common coupling, right? The generation, we have the switch, right? We have the different types of feeders. From the feeders which are connected to the various loads, right? The feeders are nothing but the high current carrying capacities, right? Which is given to the all the loads. Okay. So this is actually the actual grids, how it looks, right. You can see there is a wind turbines, energy storage systems, right. They have the fuel energy systems, and we have the natural gas. We have this the small substation. We have the grid switching station also, right. Um, right. So this is actually how the need. Then what is the need for ESS in the microgrids? What is the purpose of using energy storage in the microgrids? one thing is to we have to integrate our diesel generator to the microgrid, right? Other thing is the critical roles in the stabilizing the your frequency is also very important. You have to stabilize the frequency at all the times and the voltage profile. Voltage profile you have to maintain the voltage profile also. You have to maintain the frequency profile also. For that, ESS is very essential. It will plays a vital role for and the, during the critical conditions, right? So you have to maintain the frequency of 50 Hz, only 50 Hz. You cannot have 47 Hz, or you cannot have the 55 Hz, right? So you have to maintain the frequencies also. For that reason, we have to have the ESS in the microgrids. So that is the reason for maintaining the your voltage profile and the frequency profile. All right, the frequency should be almost at the Indian frequency of 50 Hz, right? So that we have to maintain the frequency constant, right? So energy storage will have the high performance, right? And also a very good life cycles will be there, and high efficiency also, right? And the safe operations, it is more sustainable, and it is environmentally being to material. There is no corrosive acids, right? And also the if you see talk about the low acquisition cost, right? Per dollars, it is $1. It may be certain dollars per kilowatt hours, right? And there is no regular maintenance, right? As I told, the life cycle it may be around of 5,000, 6,000. It may come for more 5 to 6 years or 10 years like that. All right. So these are the actually the energy storage in the microgrids, right? Energy storage technologies we have. These are the, again when you come to the C ultra capacitor, we have superconducting magnetic fields. We have the pumped hydro storage, the flywheels, the batteries, right? So these are the various types of the batteries, right? Ongoing grid activities. Many people are demonstrating their own things in the Rita gels in California. The objective is to reduce the microgrid system cost, right, and increase the reliabilities, right? These are the ongoing projects. So focus more on the microgrids, how the microgrids can be give the more reliabilities, right? Other countries they are making a lot of research. They are demonstrating their own ideas, right? Their objective is to reduce the microgrid system cost, right? System cost has to be reduced and give more reliabilities, provide more reliabilities for the consumers. All right. This is actually the system. All right. The difference, this is actually the difference between the actual grid, power grid as well as the microgrids, right? Uh, you can take the screenshot of this. They have made the differences between the microgrid, and the benefit of the microgrid is to have the utility grid, it is ability during a utility grid disturbance also to separate and isolate the different faulty conditions seamlessly without any interrupting the loads, right, within the microgrids. So these are the various benefits in the peak load period also. It will try to prevent the utility grid failures by reducing the load on the grids. So this is the benefit of your the microgrids. All right. If you think about the future, we have to make a lot of research, right? Please good to have a lot of the research to reduce the cost of the microgrids. All right. Um, so I'll just wind up the classes. It is almost we are at the end of the 3 hours. So I'll try to finish up. We'll wind up the classes. All right. So try to go for the making the transformation of the microgrids to become more intelligent, right? Try to use some AI into the microgrids to operate to make more faster delivery of the system and make more significantly reliabilities and the more secure. Try to provide a more secure to the systems.
Sir,
Okay. Shall I wind
sir,
up?
I am Uday.
Shall I wind up the class?
ಸರ್ ಇದು ಸಾಫ್ಟ್ವೇರ್ ಯಾವ್ದು ಯೂಸ್ ಮಾಡ್ತೀರಾ ಅಂತ ಏನಾದ್ರು ಸರ್ ಈಗ ನಿಮ್ದು ಮಾಡಲ್ ಸರ್
ಯಾವುದಕ್ಕೆ ಯಾವ ಮಾಡೆಲ್ ಮಾಡಲಿಕ್ಕೆ?
ಇದು ಸರ್ ಅದೇ ಸಾಫ್ಟ್ವೇರ್ ಮಾಡಲ್